You learned through the POGL how to find the average atomic mass if you were given the percent abundance of several isotopes along with their mass. However, in this example, what we want to be able to do is actually find the percent abundance for the separate isotopes if we're given the average. So we're working this problem backwards. In this example, we have two naturally occurring isotopes, and that is for lithium. The average atomic mass of lithium is given. Now, this information is not necessary to the problem because this information can be found on the periodic table. So if they don't give you the average, you could just look on the periodic table to find it. The question, though, is what is the percent abundance of each isotope? So lithium has two isotopes, lithium-6, which has a mass of 6.02 atomic mass units, and lithium-7 has a mass of 7.02 atomic mass units. So how can we use this information along with the average to find the percent of each one? Now, first you want to be able to reason it out. And this is helpful on multiple choice questions, as well as there'll be some more thinking questions, not necessarily math. We need to be able to determine, before we do any math at all, which one of these is more abundant in nature. Is there more lithium-6 in nature, or is there more lithium-7 in nature? And judging by the average, which is really close to 7, I can say that lithium-7 is definitely more abundant in nature. Its percentage is going to be greater than 50%. And I know that the lithium-6, therefore, has to have a percentage that is less than 50%. So you should be able to figure that out just by looking at the numbers. Whatever the average is closer to, that's the one that's the more abundant. And the closer it is to that number, the higher the percentage of that value. All right, let's look now how to solve. You want to let Y represent the abundance of one of your isotopes. For this example, we're going to let Y represent the abundance of our lithium-6. So we take the mass of our lithium-6 and multiply it by its abundance, Y. And then we add that to the mass of our lithium-7 multiplied by its abundance. However, we know the abundance of 6 and 7 have to add up to 100%, right? And 100% in a decimal form is 1. So what we've done here is we're letting Y represent the abundance, or the percentage, change to a decimal for lithium-6, and then we're multiplying that, and then adding that to lithium-7 times its abundance, and that's equal to the average. Okay, from here it just becomes a math problem. So as long as you understand this setup, we can move from here. The mass times the abundance plus the mass times the abundance. The only thing that's different is we don't know the abundance. So for lithium-6, we're saying the abundance is Y, and for lithium-7, we're saying the abundance is 1, or 100%, minus Y. Okay, so we go from there to solve. This 7.02 gets distributed to 1 minus Y, so that's 7.02 minus 7.02Y. We can combine like terms with our Y's, and we get negative 1Y. And then we subtract to move that to the other side, and we get negative 0.08 AMU. We then divide, and this is actually AMU as well, this 1 here, because these two values are in AMU. So the AMUs will actually cancel. So when we divide, we get Y equals 0.08. Now that is the percentage for Y, and Y was assigned to lithium-6. So we can say that lithium-6 is 8% if we move our decimal, and therefore lithium-7 is 92%. Okay, so this is how you find percent abundance if you know your two isotopes along with your average.